This is Algebra Lesson 1-8, Introduction to Equations. Now, this is just an introduction to equations. You'll get into more full-blown equations in Chapter 2, where we get into all of the different types of equations and the different ways of solving them. An equation is a mathematical sentence that contains an equal sign. Like we could have 3 plus 7 equals 10. That is an equation. Or you could have 3x plus 2 equals 8. That is also an equation. Anything that has an equal sign is considered to be an equation, whether or not it has a variable. An open sentence, it is an equation that contains one or more variables and may be true or false depending upon the value of the variables. So in the two examples above, 3 plus 7 equals 10 and 3x plus 2 equals 8, 3x plus 2 would be considered to be an open equation. 3x plus 2 equals 8 is an open equation, an open sentence, because until we know what the value of the variable is, we cannot tell you whether or not it's true or false. The solution of an equation is the value of the variable that makes the equation true. So for instance, in this 3x plus 2 equals 8, the solution of the equation there would be 2. Now you can use an equation to represent the relationship between two quantities that have the same value. 1 plus 1 equals 2, x plus x equals 2x. An equation is true if the expression on either side of the equal signs are equal. If an equation is false if the expressions on either side of the equal sign are not equal. For example, 1 plus 1 is equal to 3 is not a true equation, or x plus x is equal to 3x is also a false equation. So it says, is the equation true, false, or open, and explain. So if we look at the first example, example A, 3y plus 6 equals 5y minus 8. Considering they have variables on both sides and we do not know what the variable is supposed to be replaced with, in this particular case, this would be what we would call an open sentence, because we do not know the value of the variables. Now, if they were to tell us that the variable was 2, then we could tell whether or not it was true or false. Okay. Letter B, 4 times 11 equals 44. Well, 4 times 11 is definitely 44, because 44 equals 44. So this would be a true equation. Letter C, 3x minus 1 equals 17. Again, it's open because we don't know what the variable is. Okay. It depends upon what the variable is. So true, false, or open. Letter D here says, is x equals 5 a solution of 16 equals 4x minus 4? If you want to know if something is a solution to an equation, if they tell you, they give you a value and they want to know, is this a solution? All we have to do is plug in the value for the variable and work the problem out to see if it makes a true equation. So in this case, every time we're going to see an x, we're going to put in a 5. So we have 16 equals 4 times 5 minus 4. And we want to know, is that actually a true statement? So 16 equals 20 minus 4. Well, that is true. 16 equals 16. So yes, x equals 5 is a solution to this equation. Now, in real-world problems, the word is can indicate an equality. It can mean an equal sign. You can represent some real-world solutions and situations using an equation. So here's a multiple choice problem for you. It says an art student wants to make a model of a classroom. The length of the classroom is 2.4 times the width. The length of the student's model is 42 inches. What should be the width of the model? Well, if the length is 2.4 times the width, that means that we know the width times 2.4 will equal my length. That much I do know. So I'm just going to sit here and I know that 2.4 times my width is equal to my length. So I need, if all of these, says if A, B, C, and D are all possible values for the width, I just need to plug them in. So I'm going to take 2.4 and multiply it by 17.5. I'm going to take 2.4 and I'm going to multiply it by 20.5. I'm going to take 2.4 and multiply it by 82.6 and 2.4 and multiply it by 100.8. And you might ask me, why am I multiplying all of them? Why don't I just do one and when I find my answer, stop? Well, if you make a mistake, you're not going to catch it unless you test all of them. Now, obviously, I know these all have to equal 42 because we know that the length, it says the length has got to be 42. So I can automatically tell you right now that these two are going to be too long. Because if I multiply 82.6 times 2.4, it's going to be a lot longer than 42. Okay, so I'm just going to do all the math on all four, but if this was a timed test, I could literally look at this and eliminate C and D right off the bat, because they're all both longer than 42 before I even multiply them by 2.4. But since I said we should probably check all the answers, I'm going to check them all. So if I take 2.4 and multiply it by 17.5, that ends up to be 42. If I take 2.4 and multiply it by 20.5, that's 49.2. 2.4 times 82.6 is 198.24. And last but not least, 100.8 times 2.4 is 241.92. So too long, too long, too long, just right, which means our answer is A. Okay. Now, on most multiple choice tests, you can normally eliminate at least one answer that does not even make sense. In this case, we could have eliminated two. We could have eliminated C, and we could have eliminated D right off the bat because they were way too big for the value that we were looking for. And those are test-taking strategies that are good to learn. Learn what you can eliminate, and then you can focus on what you need to practice or pay attention to. All right. It says find the solution using mental math. Because this is just an introduction to equations, we're just thinking through these. I'm looking at this first problem, x plus 7 equals 13, and I'm saying, what plus 7 equals 13? And my brain goes, I don't know, what plus 7 equals 13? Let me write that down real quick. What plus 7 equals 13? And I'm like, I know that that's 6. Okay, 6 plus 7 equals 13. So my answer here has to be 6. If I look at letter B, what divided by 6 is equal to 12? What divided by 6 equals 12? If you don't know your multiplication tables, this could be a little harder to figure out. I'm looking at this going, oh, 72 divided by 6 is equal to 12. So the answer here is 72. Another way to solve equations is using a table, because that can be really helpful to organize some of your information. And we're going to be using tables later on when we do a lot of graphing. So it's probably a good idea to get into the idea of making tables and how to make up a table. It says, what is the solution of 3n plus 5 equals 26? Use a table. Let's see here. 3n plus 25 equals, or excuse me, 3n plus 5 equals 26. I'm just going to plug in some numbers for n. I know I have to do a number that is going to be at least 26, so I know 1's not going to work and probably not 2. So I will start with a bigger number. So let me start with 5. Let's see what happens if n is 5, 6, 7, and 8. So I'm going to do 3n, so 3 times 5 plus 5. The middle column is always your work column, and the end is always your result. 3 times 5 is 15. 15 plus 5 is 20. That's too small, so let's try 6. So 3 times 6 plus 5. 6 times 3 is 18. 18 plus 5 is 23. Still a bit too small. So let's try 7. 3 times 7 plus 5. 3 times 7 is 21. 21 plus 5 is 26. There we go. I think I found it, but I'm going to do 3 times 8 anyway. 3 times 8 plus 5. 8 times 3 is 24, plus 5 is 29. So if I use a table, I see when n equals 7, then 3n plus 5 equals 26. So my solution is 7. and that's a table. And some of you might be saying, why in the world would I have to do that much work? It's actually good practice to look at tables because then you can start seeing the patterns of tables. And when we get into functions and we have to actually find rules for tables, it'll be much easier. Like the number one below here, it says tables can be used to estimate a solution as well. Okay, what happens if you can't get your solution? To estimate, you find the integer values of x between which your solution must lie. For example, it says, what is the estimate of the solution negative 6x plus 4 equals 21? And again, we're going to use a table. Let's see here. If I have to have a positive number here, the best way to get a positive number here, if I'm only going to add 4 to it and I already have a negative 6 here, is let my x values be negative. So I'm going to choose negative 4, negative 3, negative 2, and negative 1. And I tend to go in order, either going down or up, just because it makes things logical, and I tend to not miss important numbers, mostly, aka the answer that I normally need. So here I'm going to do negative 6 times x, which is negative 4 plus 4. So negative 6 times negative 4 is positive 24, plus 4 is 28. Too high. So negative 6 times negative 3 plus 4. Negative 6 times negative 3 is 18. 18 plus 4 is 22. Still a bit too high. So try negative 2. So negative 6 times negative 2 plus 4. Negative 6 times negative 2 is positive 12. Plus 4 is 16. That's too low. If I try negative 1, I get negative 6 times negative 1 plus 4 is going to be 6 plus 4, which is 10. So I look at this and go, ooh, none of those numbers give me the answer. But I need to be close to 21. So it's going to be between these two numbers, closer to negative 3 than it is negative 2, because 22 is closer to 21 than 16 is. So 21 falls between 22 and 16. So my answer, so n is between negative 3 and negative 2. Probably closer to negative 3 than it is negative 2. And our question for the day today. How can you verify that an equation is true? So how do you verify that an equation is true? Please answer that at the end of your notes.